أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. إذا وقعت الواقعة ليس لوقعتها كاذبة خافضة رافعة. إذا رجت الأرض رجا وبست الجبال بسا فكانت هباء منبثا وكنتم أزواجا ثلاثة فأصحاب الميمنة ما أصحاب الميمنة وأصحاب المشأمة ما أصحاب المشأمة والسابقون السابقون أولئك المقربون في جنات النعيم. ثلة من الأولين وقليل من الآخرين على سرر موضونة متكئين عليها متقابلين. يطوف عليهم ولدان مخلدون بأكواب وأباريق وكأس من معين لا يصدعون عنها ولا ينزفون وفاكهة مما يتخيرون ولحم طير مما يشتهون وحور عين كأمثال اللؤلؤ المكنون جزاء بما كانوا يعملون. لا يسمعون فيها لغوا ولا تأثيما إلا قيلا سلاما سلاما. وأصحاب اليمين ما أصحاب اليمين في سدر مخضود وطلح منضود وظل ممدود وماء مسكوب وفاكهة كثيرة لا مقطوعة ولا ممنوعة وفرش مرفوعة. إنا أنشأناهن إنشاء جعلناهن أبكارا عربا أترابا لأصحاب اليمين ثلة من الأولين وثلة من الآخرين. وأصحاب الشمال ما أصحاب الشمال في سموم وحميم وظل من يحموم لا بارد ولا كريم. إنهم كانوا قبل ذلك مترفين وكانوا يصرون على الحنث العظيم وكانوا يقولون أئذا متنا وكنا ترابا وعظاما أئنا لمبعوثون أو آباؤنا الأولون. قل إن الأولين والآخرين لمجموعون إلى ميقات يوم معلوم. ثم إنكم أيها الضالون المكذبون لآكلون من شجر من زقوم فمالئون منها البطون فشاربون عليه من الحميم فشاربون شرب الهيم هذا نزلهم يوم الدين. نحن خلقناكم فلولا تصدقون. أفرأيتم ما تخلقونه أم نحن الخالقون نحن قدرنا بينكم الموت وما نحن بمسبوقين على أن نبدل أمثالكم وننشئكم فيما لا تعلمون ولقد علمتم النشأة الأولى فلولا تذكرون أفرأيتم ما تحرثون أأنتم تزرعونه أم نحن الزارعون لو نشاء لجعلناه حطاما فظلتم تفكرون إنا لمغرمون بل نحن محرومون أفرأيتم الماء الذي تشربون أأنتم أنزلتموه من المزن أم نحن المنزلون لو نشاء جعلناه أجاجا فلولا تشكرون أفرأيتم النار التي تورون أأنتم أنشأتم شجرتها أم نحن المنشئون نحن جعلناها تذكرة ومتاعا للمقوين فسبح باسم ربك العظيم فلا أقسم بمواقع النجوم وإنه لقسم لو تعلمون عظيم إنه لقرآن كريم في كتاب مكنون لا يمسه إلا المطهرون تنزيل من رب العالمين أفبهذا الحديث أنتم مدهنون تجعلون رزقكم أنكم تكذبون فلولا إذا بلغت الحلقوم وأنتم حينئذ تنظرون ونحن أقرب إليه منكم ولكن لا تبصرون فلولا إن كنتم غير مدينين ترجعونها إن كنتم صادقين فأما إن كان من المقربين فروح وريحان وجنة نعيم وأما إن كان من أصحاب اليمين فسلام لك من أصحاب اليمين وأما إن كان من المكذبين الضالين فنزل من حميم وتصلية جحيم إن هذا لهو حق اليقين فسبح باسم ربك العظيم.
Light, another question, gentler yet no less decisive, emerged. What turns a dead planet into a world that breathes? The answer does not lie in accelerators or equations, but in a clear liquid so familiar we forget it is a miracle: water. On a cosmic scale, water is rare. Most of space is cold vacuum. Most planets are dry rock or toxic gas. Yet on Earth, water covers more than 70% of the surface, seeping into every crack of stone and every living cell. It is not merely favorable to life, it is essential. And so the question, where did water come from, is not just geological or astronomical. It is a question about our own origin. For decades, the most popular hypothesis sounded poetic. Comets. Icy wanderers from the outer solar system, carrying frozen water, crashing into the early Earth like messengers from afar. The idea was so compelling it became intuitive. But science does not live on intuition. It lives on evidence. When researchers compared hydrogen isotope ratios in cometary water and ocean water, romance gave way to reality. They did not match. Water from many comets contains far more deuterium. The cold but necessary conclusion: comets could not have been the primary source of Earth's water. This forced a second hypothesis to be reconsidered. Water was there from the beginning. As Earth formed from a disk of dust and gas around the young sun, could minerals and grains have held water locked within their structure? It sounds contradictory. Early Earth was infernally hot. Yet here science uncovered a beautiful paradox. Water does not exist only as liquid or ice. It can hide within crystals, minerals, and chemical bonds that withstand extreme heat. This opens the possibility that Earth was never truly dry. The strongest evidence comes from ancient zircon crystals, geological time capsules. They show that liquid water existed on Earth's surface only a few 100 million years after formation, far earlier than once believed. Water did not arrive late to grant life. It was already waiting. A third hypothesis shifts the story slightly outward. Asteroids. Not icy comets, but water-rich, rocky bodies from the asteroid belt. Carbonaceous chondrite meteorites that fall to Earth today contain water with isotopic compositions nearly identical to ocean water. This was a crucial discovery. It suggests that water arrived via ordinary collisions during planetary formation. No distant messengers required, only ancient wandering stones. But the story does not end there. Earth did not grow up in peace. It endured catastrophic impacts, the greatest of which formed the Moon, an impact powerful enough to melt the planet into a magma ocean. The obvious question follows: how did water survive? Once again, intuition fails. Water does not necessarily evaporate and vanish. In a magma ocean, it can dissolve, hiding deep within the planet. As Earth cooled, the water escaped, condensed, and rained down over millions of years. The first rains were not life-giving showers, but rains that created oceans. Today, the most accepted view does not choose a single source. Earth's water came from many origins. Some inherited from initial material, some delivered by asteroids, and perhaps a small fraction from comets. It existed earlier than we thought and proved far more resilient than we once believed. NASA often summarizes its search for life with a simple phrase: follow the water. Where there is water, complex chemistry can emerge. But when we look back at Earth, we see the reverse is also true. Water followed us from the very beginning. And here, the story of water connects seamlessly with the story of mass. If the Higgs field is the condition that keeps matter from passing through itself, then water is the condition that allows matter to interact in living ways. It is no accident that life on Earth relies on this solvent. Water stabilizes temperature, transports energy, and allows reactions to occur without destroying fragile biological structures. Carl Sagan once wrote, "We are made of star stuff." But perhaps more fully it should be said, we are made of star dust, held in place by mass and awakened by water. When you look at a drop of water, you are not just seeing a liquid. You are seeing the history of the solar system, ancient collisions, a planet that nearly became barren, yet somehow turned blue. And it is precisely this fragility, water can be lost, oceans can evaporate, that makes this story not just about the past, but a reminder for the present. In the next part, as we turn to extreme weather and a changing climate, remember that every storm, every raindrop, every rolling ocean traces its origin back to this ancient story. Water did not only create life, it is still writing Earth's fate, day by day, breath by breath. If water is the condition for life to begin, then the movement of water and energy determines how fragile that life is. After tracing ancient drops that survived the moon-forming impact, our story no longer rests in stone or primordial oceans. It begins to move, evaporating, swirling, accumulating, and crashing back to Earth. When water meets heat, when oceans meet wind, when the atmosphere meets imbalance, weather is born. And in the modern world, that weather is becoming more extreme than ever. From space, Earth appears gentle, thin white cloud bands wrapped around a blue sphere. But beneath that calm exterior lies a massive energy machine, where heat from the sun is absorbed, stored, and released by the oceans as storms, especially tropical cyclones, the largest and most powerful weather systems on the planet. A storm's journey often begins far away, as small atmospheric disturbances over Africa. These waves drift into the Atlantic, where warm ocean water acts as fuel. At first, they are just scattered thunderstorms, but when conditions align, warm water, moist air, and Earth's rotation, they begin to spin, grow, and intensify. From an anonymous disturbance, a storm can evolve into a devastating hurricane, carrying energy equivalent to tens of thousands of nuclear bombs. Inside every hurricane lies an almost perfect structure. The eye, an eerie calm at the center, is surrounded by the eye wall, where the strongest winds and heaviest rain occur. Near the ocean's surface lies the air-sea boundary, where the ocean feeds energy directly into the atmosphere through water vapor. This is where storms feed. The warmer the ocean, the longer and stronger the storm can grow. And here lies the critical point of the modern story. The oceans are warming, not by feeling, but by measurement. Warmer water injects more vapor into the atmosphere. Vapor is not just rain, it is fuel. This explains why today's storms often produce more rainfall, maintain strength longer, and become harder to predict. Storms are not just wind, they're expressions of planetary energy imbalance. Alongside hurricanes is another phenomenon, smaller in scale but no less terrifying: tornadoes. If hurricanes are slow energy engines, tornadoes are atmospheric blades, appearing suddenly, destroying briefly, then vanishing. For decades, tornadoes were considered a springtime feature of a specific region in the United States, Tornado Alley. But in recent years, old rules have begun to crack. Tornadoes now appear in winter, farther north, and under conditions once thought unsuitable. Scientists trace the cause to La Niña and the jet stream, high-speed winds in the upper atmosphere. As Pacific Ocean temperatures shift, the jet stream can strengthen and migrate, creating stronger, low-level rotation. The result: violent tornadoes in places unprepared for them. What is alarming is not only intensity or frequency, but spatial shift. As Tornado Alley moves northward, densely populated cities, not designed for violent tornadoes, fall into danger zones. This is not science fiction, it is an observed trend. All of this forms a unified picture. The climate is changing, and weather is how that change manifests in daily life. Storms and tornadoes are not new enemies, they are ancient phenomena. What has changed is the energy context in which they exist. A warmer Earth gives weather systems more fuel, and the result is extremity. From a cosmic perspective, this is a profound reminder. As Carl Sagan wrote, "The Earth is a very small stage in a vast cosmic arena." On that small stage, climate is the backdrop, and weather the most dramatic scenes. They remind us that even as we understand the Higgs boson, the origin of water, or planetary formation, we still live within a fragile system where small temperature shifts can amplify into catastrophe. This part of the story is not meant to instill fear, it is meant to restore proportion. Storms and tornadoes do not care about borders, history, or intention. They obey physical laws, laws written in the first second of the universe, later interpreted by water and energy on Earth's surface. And as we move to the next part, mass catastrophes and Earth's death, remember that today's storms are not the end. They are early signs, small ripples that reveal how a planet responds when ancient balances begin to slip. Earth is still telling its story, not in words, but in wind, rain, and the increasingly violent motion of a living world. If storms are Earth's violent whispers in the present, then the chain of great catastrophes is the long story it will tell in the distant future. A story without emotion, without punishment, only the cold consequence of cosmic laws. When we widen our view beyond human lifespans, beyond civilization, beyond even historical memory, Earth no longer appears as a home, but as an aging entity, changing and ultimately disappearing, like all stars and planets. In cosmic time, catastrophe is not abnormal. Asteroid impacts have repeatedly marked tragic chapters of life's history. A sufficiently large impact can darken skies for years, cool the planet, collapse food chains, and erase dominant species. The question is not if this will happen again, but when. Earth still moves through a cosmic firing range, where wandering bodies are indifferent to fragile life on its green surface. Even without impacts, Earth faces its own cold cycles. Global ice ages may return as orbits, axial tilt, and continental distribution change. Ice could spread from poles to equator, locking water in massive caps, turning oceans into salt deserts, forcing life into rare refuges of heat and light. This is not sudden apocalypse, but slow decay over tens of thousands of years. Farther still, continents will drift, collide, and merge into a new supercontinent. But instead of lush forests and seas, its interior may become arid and scorching, far from ocean moisture. Stable climate, the cradle of civilization, would vanish. Earth would enter an era where large, complex life struggles to persist. Meanwhile, volcanoes and deep geological processes continue. Prolonged eruptions could release massive greenhouse gases or cooling aerosols, pushing climate into new extremes. Ocean acidification would intensify as CO2 dissolves into seawater, collapsing coral ecosystems and marine food webs. The result would not be one disaster, but repeated mass extinctions, each erasing biodiversity that took hundreds of millions of years to evolve. Yet all of this is merely prelude to the fate written by Earth's central star. The sun is not immutable. It is aging, slowly, inevitably. As hydrogen fuel dwindles, the sun will grow hotter and brighter. Long before it becomes a red giant, increased energy will be enough to evaporate Earth's oceans. Water, life's foundation, will fade from the surface. Life will retreat. No forests, no large animals, no blue oceans. Only extremophile microbes, hidden deep in rock and hot vents, clinging to existence under conditions once deemed impossible. Earth will resemble an alien world, familiar in mass and orbit, alien in life. Eventually, the unavoidable moment arrives. The sun expands, engulfing nearby planets. Earth may be swallowed, melted, or torn apart by immense gravitational forces. This planet, once home to oceans, forests, and intelligence, will cease to exist as a distinct world. It sounds bleak, but the universe rarely tells stories through human tragedy. When Earth disintegrates, nothing truly disappears. Atoms that formed mountains, seas, living bodies, even human brains, will return to space. They will merge into gas and dust clouds, becoming material for new stars, new planets, and perhaps new life forms never imagined. Carl Sagan once wrote, "For small creatures such as we, the vastness is bearable only through love." But he also reminded us, we are a way for the cosmos to know itself. If this is true, then Earth's death is not the end of the story, but a transition. The universe does not lose awareness, it merely changes form. What makes this story profound is not fear of apocalypse, but scale. All of human civilization is a thin mist on the surface of planetary history. Yet in that brief moment, Earth gave rise to biology, consciousness, memory, and the ability to reflect on its own origin. That is not trivial. When you hear of Earth's death, remember the universe does not operate on loss. It operates on cycles. The destruction of one world becomes the birth material of another. No tragedy, no salvation, only continuation. And when the story closes here, what remains is not despair, but a strange stillness. Earth will go, but nothing that existed upon it will vanish completely. It will return to where it came from, the universe, quietly, unnamed, yet full of potential for another beginning, somewhere at a time we will never witness. The core message of this journey lies in a deep paradox. The entire history of the universe, from the birth of stars to the emergence of life to Earth's death, may have been shaped within a single second. Not in a mystical sense, but in pure physics. Natural constants, fundamental forces, expansion rates, the fragile imbalance between matter and antimatter, all were locked into place in that primordial moment. Change any one slightly, and our familiar universe would not exist. This leads to a realization both humbling and overwhelming. The universe was not designed for humans. It did not aim to create life, let alone consciousness. Yet, through conditions of astonishing precision, it allowed life to arise. As physicist Steven Weinberg wrote, "The more the universe seems comprehensible, the more it also seems pointless. And in that pointlessness, humanity must ask, if meaning is not given, where does it come from? The answer lies in fragility. Humans are products of extremely rare, temporary, and delicate conditions. A planet at the right distance from its star, an ocean lasting long enough for complex chemistry, an atmosphere that stays bound, a Higgs field stable enough to grant mass. Each could have failed. Break one link, and there would be no biology, no history, no one asking about origins. This does not make humanity meaningless. It makes every moment denser. If life is rare, conscious life is rarer still. And if consciousness can reflect on the universe that created it, that is not a trivial accident." Carl Sagan captured this spirit in a single line. "We are a way for the cosmos to know itself." Humans do not stand outside the universe. We are part of the process by which the universe briefly observes itself. Understanding the universe, then, is not about memorizing facts or laws. It is a shift in inner position. When you realize the atoms in your body were forged in stellar cores, that the water you drink predates Earth, that your lifetime is a thin slice in billions of years, you no longer see yourself as central, yet no longer meaningless. This is the most delicate point. Small does not mean insignificant. In an infinite universe, finite existence does not diminish value, it gives it weight. Albert Einstein once wrote near the end of his life, "A human being is part of a whole, called by us, universe." He experiences himself, his thoughts and feelings, as something separated from the rest, a kind of optical delusion of his consciousness. To understand the universe is to begin seeing through that optical delusion, recognizing separation as temporary. This message does not call for fear or blind hope. It invites a different posture, calm awareness. Knowing Earth will pass need not bring despair. Knowing humanity is brief need not breed arrogance. Instead, we can choose responsibility toward the planet, toward each other, toward the present moment. Not because the universe demands it, but because it is all we truly have. At a deeper level, this message is also comfort. If everything is shaped by physical conditions set in the first second, then you need not carry the burden of cosmic meaning. The universe does not ask you to prove anything. It simply allows you to exist long enough to feel, think, love, and question. And perhaps that is the most beautiful thing. Not immortality, not eternity, but that in a brief moment of infinite time, the universe produced a species capable of looking up and asking, "Where did I come from?" As philosopher Alan Watts said, "You are an aperture through which the universe is looking at and exploring itself." When this video ends, what remains is not anxiety about Earth's death, but a quieter feeling. You are exactly where you belong in the universe. Not too large to bear everything, not too small to matter. Simply part of a very long story, one that began in the first second and will continue long after we are no longer here to tell it. And perhaps, simply being able to listen to that story is already enough.